So, hello everyone, and welcome to this weekly session that we conduct, Ask AuxEn Anything. And as you all know, it is an online platform for civil structural engineers to interact with us and ask their doubts or queries that they may have related to steel or RCC design concept, any project that they are doing, or construction site issues. So, this is the 47th episode that we are conducting, and let us begin by taking the queries that have been asked. So I'll share my screen and we will start taking the queries one by one. So the first I'll take the queries from Google form, and then we will take the queries from uh, the live comments. I'm just trying to see where did we till which query did we finish in the last session. Yeah. So first query is from engineer Shirish Patil. He's from Kolhapur, Maharashtra, and he is a working professional. So his queries are. Let me just copy them. So these are his list of queries. I have some doubts regarding the foundation design of a wall for a wall. Should we check punching shear for wall resting on raft foundation? So for example, I'm showing you the plan view. This is a wall and it is resting on some foundation. So now he's asking, should we check punching shear for a wall resting on raft foundation? So yes, you should check punching, you should check one-way shear, and then you should check for flexure. So these are the three actions that we check our general footings for. So same should be done over here also. Now he is asking, should we check? So yes, you should check. Yes, for one-way shear, for two-way shear, and for flexure. The thing is that generally you will see that because of the shape of the wall and because of the relatively large perimeter that it has, the two-way shear or the punching shear may not be the critical action, may not be the critical action. Okay, and the critical action which decides the footing thickness uh, generally would be the one-way shear. So even though you have to check for punching or you have to check for two-way shear, but in geometries like this you will find that punching is not the dominant or deciding action, and it is rather the one-way shear action. Next query is, when checking for one-way shear, should we treat the wall similar to a column? Yeah, d distance. So you should check at d distance in either direction. Check at d distance. In cases where the critical section does not exist on one side of the wall because of the plot constraints, how should that situation be addressed? So for example, your case is something like this. In plan, I'm just talking about the one way shear check right now, that your wall was right over here. So in this case, the d distance lies outside the footing, okay, outside this footing because the wall was right on the edge. So in this case, one way shear in this direction is not important. Then you check for one way shear over here at d distance. This you need not check, you check in this direction only. And then for punching also, you remember that it will have a reduced perimeter because of this assembly. Remember that the perimeter at d by 2 will be reduced because it's a edge condition. Okay, so you do it like this. Of course, then uh, if this is an eccentric thing, you have to take care of the eccentric moments, but I'm not talking about eccentric moments. I'm just answering to your query related to shear check. I have seen many consultants model walls as beams to avoid punching and one way shear check. Is this approach correct? No. No, no, wall as beams maybe because they might be taking the forces from ETABS, let's say to safe, and that's why when you bring a model from ETABS to safe, generally there is a wall property assigned. So maybe to them, to that they are assigning beam property. I don't know, but whatever property you are assigning, that's immaterial. Punching checks should not be avoided because punching checks are the crux of foundation thickness calculations. So whatever you model, however you do so, punching checks and shear checks cannot be avoided because they are the sort of basis for thickness calculations. All right. So these were the queries from engineer Shirish Patil. Now we move on, and next query is from engineer Manjunath, but he has not put any query. Next query is from engineer Ravi Chandra. He's from Hyderabad and he is a postgraduate student. I think he was a working professional. He is asking if not available for software when we have to design the water tank, how to design the tank by using IS 3370 part 4. So in IS 3370 we have done this entire course on liquid retaining structures. Uh, so IS 3370 is the series of what should I say, is the series of codes for liquid retaining structure design, and in that there is a part 4 which deals with the design tables. Okay, so he is asking, his question is related to how to read from those tables. So if there are, see, I had asked you yesterday also, if there's a specific doubt related to which table, it will be more helpful because there are a lot of different tables that you have. So if there is any specific doubt related to table, please tell me. Okay, that where and in which condition or under which situation you are facing doubts. So specific doubts, please. If you have a specific doubt related to this, it will be more helpful. Otherwise, there are several uh, tables that are given in the 3370. So, and then there are conditions given, there are moment coefficients given, shear coefficients given. Using them you can calculate, but see, remember the limitation of table is that they are only good for rectangular or general shapes. They are good for only rectangulars or square shapes, tanks. You cannot use these table for multi-compartment tanks, and then beyond a certain point, uh, or let's say you cannot use these tables if in multi-compartment tanks you have multiple or different liquid heights, liquid fill heights. So it becomes more and more complicated to use these tables beyond a certain level of complexity in your uh, liquid retaining structure layout. So for easy layouts you can use these tables. For quick references you can use them, but generally I find that use of modeling it on ETABS or STAD is more helpful. We have done an entire course on liquid retaining structures where we have dealt in depth about the liquid retaining structure design as per the IS 3370 2021 series of codes. So related to tables, if you have some quick, if you have a specific doubt, please ask. All right. Okay. Then we move on to next query, and that query is from, let me see. Uh, Next query is from engineer Umang Patel. He is a postgraduate student from Nashik. And what is he asking? Let's see. And he is doing a lot of good work on his thesis, which is based on the IS 18168. So and then he has shared some image. I think it was on WhatsApp. So let me just go to WhatsApp and check. Uh, Wait a minute. I'm just looking into WhatsApp, trying to see where he has shared this image. How many of you have worked on 18168 or have used 18168? No one in the audience? Just a minute, please. Where is that image that he had put? I think in one of the groups he had put that image. Yeah, I guess that is the image. Is this the image? Mr. Umang, if you are in the audience, I could see him in the audience, but I don't know whether this is the image to be referred to. Yes. Okay. Let us see what he's asking. What he's saying. As per 18168, if we provide bracing connections at beam to column connection, then beam to column connection is to be designed to resist movement equal to beam capacity. Yeah, but generally, if we provide bracing, we provide shear connection for beam to column connection. If provisions of IS 18168 are followed, then it will make the yes, correct. But if we provide alternate V and inverted V placing as shown in the image, see, so this is the sort of issue with 18168 right now, that when you are using the special concentrically braced frame systems, or if you are using the eccentric braced frame system, let's talk about the SCBF right now. So in SCBFs, it wants you to have the beam to column connection also as a moment connection. Okay. So this is the requirement of 18168 as of now. So this is a slightly, I would say, a stringent requirement, because then you end up having very heavy connections for the beam to column, because then you have to design not only them as a moment connection, but then you have to design them, if I remember correctly, for 1.1 times Ry times Fy into Zp of the beam. Yeah, if I remember correctly, this is so capacity 1.1 Ry you have to multiply with the plastic moment carrying capacity of the beam, and you have to design the beam to column connection as a moment connection for these levels of moment, which turns out that your beam to column connection is pretty heavy designed, so to say. Okay. Yeah. So this is, as he has rightly pointed out, is a problem with IS 18168. If you compare the same thing with AISC 341, if you compare the same thing in AISC 341, they give you options. Okay. So they give you options to decide the type of beam to column connection in SCBFs. So there are three options given. Either you can design it as a moment connection, same as 18168, or you can design it as pin or shear connection. Okay, absolute, just a shear connection, or you can design it as connection of an OMRF, ordinary moment resisting frame system. So they give you three options in AISC 341, and that makes a lot of sense, because then what we do is that in SCBFs we will have the beam to column connection designed as shear connection or pin connection, not as a moment connection. Okay. And that makes a lot of sense because this is an SCBF system. So loads are supposed to flow through the axial tension and compression in the bracing, not through the moment frame action. So this option that AISC 341 gives you is much more logical. But as of now, this is not available in the 18168. So that's a problem. Yes. Okay. And even in the V or inverted V bracing, so see, as of now for SCBF, CBFs, in either cases, the 18168 wants you to design the beam to column connection as a moment connection only. They have not given you any other alternate. So you in such case you may refer to AISC 341. Okay, so then we move on to next query. This is from engineer Kunal Gabhane. He is from Nagpur, and he is a working professional. So he has asked these questions. Let me just copy it and paste it over here. And then he had shared one image also. So let me bring that image also. Uh, yeah, this is his image. So he's saying for pad footing design, if the water table is at ground level, so for sliding check, resisting force is equal to coefficient of friction into net downward force. Resisting force should be greater than sliding horizontal force. While calculating net downward force, I have considered the submerged weight of column below ground level, foundation and soil over foundations. Now, what do you mean submerged weight? Have you not taken the dead load coming from the column? The dead load and some amount of live load coming from the column, because that will be a major component that you should consider. His question is now, should I also need to again subtract uplift forces under the foundation for net downward force calculation? He is thinking, I think as the water is at ground level, water will be on top of foundation on all sides. So for uplift pressure at bottom of foundation, net pressure will be balanced. So no need to subtract uplift forces again. But I first of all, for a normal pad footing, which is of your building, I'm supposing that this pad footing is for your building. Why do you even think that sliding will be an issue? So why do you think sliding will be an issue for an isolated footing of a building column? So sliding should not be an issue in such cases, first of all. Yeah, because see what is happening, that water, if at all it is acting on such a small cross section area of your footing sides and column sides. So the lateral force or horizontal force acting is so small, and it is getting resisted by mu times the normal force. And this normal force will consist of the reaction from the column, and that will be so high. Okay, so why why at all you are wanting to check the sliding? That is my first query. Second query is that second thing is that, let's say if you want to check, now you are considering this soil submerged load on this. Okay, and then you are asking whether I should subtract the uplift pressure from here. So subtracting uplift pressure, because he's saying that I have already subtracted once in the submerged weight. No, I think you should still subtract. So this submerged weight was for the soil, because of the water table it was causing buoyancy in the soil. But then the uplift pressure will also try to lift up your footing. So whatever is the downward dead load plus some percentage of live load, from that you subtract the uplift pressure into the footing area, that you subtract, This you multiply by the coefficient of friction. This will be the downward resisting force. Sorry, this will be the resisting force against sliding, and then the sliding force will be the water pressure multiplied by these exposed areas of footing sides and column sides. So this is how you can calculate, but I'll again repeat that it's not required to check uplift for isolated footings, especially when these are of building like structures. Okay. Mr. Umang Patel is asking, in continuation to last question, if inverted bracing is used where the gusset plate is connected to mid length of the beam, that beam shall also have moment connection. For that, the code is not very clear. For that, the code is not very clear right now. So I think this comes under the multi-tiered braced frame systems, right? This will be called as the multi-tiered braced frame systems, I believe. So for that, I also need to check what is the codal provision. But as far as I remember, all the beam to column connection right now, even this, which is in between, this also I think has to be moment connection, if I remember it correctly. Although I will also have to refer to the code once again. Probably you will find it under the multi-tiered bracing section that is there in the 18168. Okay. All right. So this was Engineer Kunal's query on isolated footing uplift check. Now we go on to next question, and that has been asked by. Let me see. This query is from Engineer Raghav Sharma. He is a working professional from Delhi, and he is asking, I am always in this confusion. I am always in this confusion that if I provide kind of steel beam cantilever from steel column and knee bracing below it. So he is having this type of a column. I am drawing the elevation, and let's say these were the flanges, steel column it is, and then he has taken a steel beam cantilever from the face, and to support it he has put a knee brace over here. This is called as a knee brace. So he's asking where to provide release, and whether should I use knee support as truss member. Now, why do you want to provide release anywhere, by the way? Don't provide release anywhere. Let this be. Okay, so if you, okay, wait. If you want to have this, okay, let's see. If you want to have this beam column connection, and if you want to have a shear connection over here, probably because you are not able to create a moment connection, so you may do this, that you may provide a shear connection here, and then you are getting a prop from this knee brace. So in such case, if this is the strategy that you are adopting, then you can have a release at this location. Okay. Now sometimes what you may choose to do as a designer, that you will try to have a moment connection at this end also, and then to control the deflections, let's say you will also provide a knee brace. So in such a situation, you do not provide any release over here. But if you want to rely on the knee brace and have this as a beam that is just resting between these two items in shear, then you can have a release over here and then provide this knee bracing. Now in the knee bracing, do not give it as a truss member, because what will happen that if you give it as a truss member, no moments it will take. That will be a problem, because you're not going to create such a thing in your actual connection detailing. So do not give a truss member to knee brace. Okay. And also, if I am supporting a pipe on it and supposing longitudinal, so he is saying there are some pipes on it, and it's supposing longitudinal force. So I don't understand longitudinal force. I am assuming it is perpendicular to the screen. His longitudinal force is perpendicular to screen. So in that case, what kind of an arrangement should be provided for columns attachment. So if you are having longitudinal force, just see if it is creating some torsional forces in your beams. Okay, that you will have to investigate, and for that you may have to provide, let's say in plan view, what you can do, that in plan I'm now showing you. Suppose this was your one column, another column, and this was another column. Where is it? This was another column, and then you had these beams coming out, cantilevers, and these were, you had provided knee bracings below them. Now there are some longitudinal pipes running like this, and as I understand, your longitudinal forces are in this direction. So what you can do in such cases is you can try to connect these elements together. Maybe think of providing some bracing between these beams to take care of the torsional forces that may get generated on this blue colored beam. So to take care of the longitudinal forces along the length of this pipe, you provide some bracings, okay, in between these cantilever members as shown. This is the plan view. Also, you can think of connecting these columns either through elevation bracings or some tie beam arrangement. So this will help to make your system better against those longitudinal forces. Clear? All right. So this is what you can do. Then let's move on to next query. Next query is from uh, who's asking? Engineer Sanchit Rana. He is a working professional, and he is saying, he is asking rather, he is a working professional from Chandigarh. I think he is asking about the upcoming course that we are going to start, RCC design and detailing using ACI codes. So this course will be a course based on RCC design detailing based on the American ACI codes, ACI 318, and also the loading code. So he is asking, in this course, will you teach as per the seismic and wind analysis? Yes, we will do both. We will do the seismic wind analysis using some manual calculations also. And of course, then we will apply those on our buildings in ETAPS. So first we'll do some calculations for load calculations using manual methods, and then we will apply them in the software ETAPS. His next query is, if I want to work on Middle East and for that international code is necessary, so this course will provide me enough knowledge. Yes, in this course, as I told you, we will be covering the RCC design based on ACI codes from the basics, right, from the scratch. So if you are looking to work on some projects uh, for I mean, if you want to work on projects using the international codes, especially the American codes in this case, this course will be very helpful for you, because we are going to deep dive and do the RCC design, discuss the RCC design, uh, including manual calculations, conceptual things, working on the software, everything from the very basics. So I think this course will be helpful for you. Okay. Right. Next query is from engineer Vineet Kumar. He is a working professional from Patna, and he is asking, while calculating the pile capacity of a double underream pile using 2911 part 3, consider a 300 diameter pile. Let me just open the 3911 pile 2911. Sorry, not 3911, 2911 part 3, table 1, which gives you the approximate capacities for an underream pile in sandy or clay strata. So he is referring to that table. Where is that table? The table is given right at the end of the code. Just a minute. Yeah, this is the table. So let's see what is his query. My With a 5 meter length in high water table zone, for the first 3.5 meter, the tabulated value must be reduced to 75% of the original value. Oh, is it? I didn't know. Is this the condition for high water table in piles? I didn't know that. Anyone in the live audience, can they just confirm? Is this condition for reduction given in the code for high water table locations? So Mr. Vineet is saying if the water table is high, you need to reduce the pile capacities as given in this table 1 by 75%. Oh, I didn't know. Thank you so much. Yeah, I just saw this. So I have been using this table for more than 10-15 years, but this thing I didn't know till now. Very interesting. And I can see from here. Yes. So this is the clause. So he is referring to this clause. The safe loads should be reduced by 25% if the pile boreholes are full of subsoil water of drilling mud during concreting. Interesting. So, okay, got it. Thank you, Mr. Vineet, for first of all for highlighting this point. So, what he's saying, let's say this is your pile bore, okay, and suppose your water table rises till this. This is the water table. Now you have bored a pile. He is saying in 5 meter length pile, and he is saying, I guess, that after 1.5 meter, this starts water table. So yeah, so let's say you do the reduction for this below 3.5, and okay, I'm not sure about the diagram right now. Where is this water table? But logically speaking, for the next increase, that means if you are going beyond the length of pile and going for incremental increase for the next zero point 0.3 meters also, I think it should be made 75%. Yeah, because then at below depths also you are getting water table. So logically speaking, you have to do this reduction for the below depths also. So any depth or any length, let's say any length of the pile after the water table has been reached should be considered in making those reductions uh, for the pile capacity. Yeah, so you should do it. Very interesting. I didn't know, so I must thank Mr. Vineet for pointing this out. Good. Next query is from Engineer Umang Patel. He had asked a query earlier also. He is saying, no, so I think we have already answered that beam to column connection, even for OC, even for the SCBFs, have to be moment resisting. So the R factor has to be the same as SCBFs. No need. It's not a dual system. It still remains an SCBF. So the R factor shall be as per the SCBFs itself. And for the split X type bracings, as we have seen in the earlier image, it will again not be called a dual system. It will still be called as an SCBF, but you still have to do the beam to column connection as a moment connection. Okay. All right. Then we have the next query from Engineer Vasan Dev. He's from Mumbai and he's a working professional. So he is asking, I would like to know the design of lift core. I would like to know that while designing of the lift core, do we need to provide different peer labels to each leg of the core or same peer labels for all legs? Because if we provide different peer labels, PT comes more. See, so if this is your wall in plan view, ideally it is always recommended, or I would recommend you to provide different peer labels. The reason for providing different peer labels is because what happens in your building plan, generally these different legs may be subjected to different movements and different axial forces. So here these legs are usually subjected to different uh, axial forces and different moments. So because of this, what may happen now? Consider this as a column in itself. This is also a column in it. It's a wall, but the design procedure remains similar to that of a column. And let's say this is your PM interaction curve. So depending on the combination of moments and axial forces, you may fall in different regions of this PM interaction curve, right? So treating it as a one section is not a very correct way of doing it. So it is always recommended that you should consider these different peer labels. You should consider these different legs as independent elements, and then for each leg, whatever is the axial force and bending moment, you find out the reinforcement percentage accordingly. So that means assign different peer labels to the different elements of your wall. Okay, and you have answered the query yourself. If you give same peer label to all the leg, if you give the same peer label, what will happen? It will get take it it will just add up all the axial forces. It will algebraically add up the moments also, and it will then start taking this as the entire cross section. Okay, so assigning one peer label may not give you the correct picture, because each leg may have some different P and M combination. So assign different peer labels to different legs of your wall. Okay. So this is the most practical approach. Whatever is the shape. So sometimes you may get a shape like this where there are two lift cores. So in such cases, what I will recommend, you give this separate peer labels. So each leg, try and give the separate peer label. Got it? Okay. So this was engineer Vasan from Mumbai. Now we have a query from engineer Suraj. I think the same query was asked in the last episode also. Let's see what he's asking. So this question is from engineer Suraj Dodari. He is from Bengaluru and he's a working professional. And I think he has shared some image also. So let me open that image and see what he has shared. Okay, so this is the image. So this is his image. What is happening? He has two common basements, B2, B1. Then first to sixth floor are parking floors. And then these are the two tower portions A and B going till 40th floor. So his first query is, should I model individual tower models A and B above podium while modeling full integrated model, that is backstay model? Should I match EQ shear for podium or ground level, and why? If we get higher EQ shears on tower B as compared to tower A, individual model, should I match EQ shear for full model by considering tower B? Hmm? Okay, so first what you should do is you can try to make a complete model that will have everything right from the basement to 40th floor. You first make a complete model. Let's call it the full model. Okay. Now for the earthquake behavior, earthquake forces. Now that is slightly tricky. Let's say here you are getting the basement walls. Till here you have the basement walls. Okay. And this is the podium slab. And then you have, okay, he is calling this also as a podium slab. And then you have your column systems, whatever. And then a few of the columns will go right till the tower. So should I model individual tower A and B above podium cover or above ground? I think you should try and model it above ground, individual models. Or in fact, what you can do is, uh, let's say in plan view, this was the situation you had, and this was your tower A, and this was your tower B, and below that whatever was there, and then this line was the basement, maybe of a larger. So these were basements, these were the multi-level car parkings. This was the basement was having a larger footprint, car parking was having a slightly lesser footprint, and these were your towers. So I think individual model for for approximate earthquake calculations, you should try to incorporate everything, some portions of A along with the adjacent uh, parking and the adjacent or the basements at the bottom. This also you should try and include in your model. Now, how much you should include, that I don't know actually. That will depend on the type of geometry you have. So those individual models then you can use for some EQ calculations. So you perform some basic EQ calculations on them. Okay, to just to find out the story level forces. Now those story level forces then you can apply over here. All right, those story level forces you can apply over here in the main model. So first I made some small models. From there I got some story level forces. Those I put it over here as diaphragm forces. Now the EQ shear, we have already tried to answer this, that you should try to match the EQ shear wherever the backstay effect is such that there is a reversal. So if you get reversal at podium, then in my opinion you can match the uh, shear at this level. If you get a reversal at the ground floor, shear reversal, then you may try to match the shears at the ground floor level. If you're not getting any shear reversals, then you just observe what are the shear forces you are getting at the base, and then accordingly try to do the base shear matching between the dynamic and static. Again, this is my opinion. You don't get any such directions or guidelines in the code as of now. Then he is asking, if we get higher EQ shears on tower B as compared to tower A, should I match EQ shear for full model by considering? No, no, individually you should try and match the shears. So for this model, you will get some shear force distribution. For this model, below the elements, you will get some shear force distribution. Try to, okay, but individually you will not be able to match. That's what you're saying. Okay, so then try to have a shear scaling so that you are able to match it with the lower value instead of matching it with the higher value. So let's say if your tower B gives you the lower shear, tower A is giving you the higher shear, you match it with the lower shear. That way you are staying more on the conservative side, and I think that is the correct way of doing it. So in such cases, this type of jugaad work you can do. There are not many guidelines given, but this is a approximate process that you can adopt. Also remember that in such cases, wind might be the more governing criteria, and in such cases the wind, anyway you will be doing some wind tunnel testing, and you will be getting individual forces from there. So these types of structures without wind tunnel should not be done. So from there you will get a proper uh, story forces on each floor separately. So wind is comparatively simpler over here, because those outputs you will be getting, sorry, those inputs you will be getting directly from a wind tunnel test. This earthquake becomes slightly tricky, especially in the backstay analysis. Okay. Next query is from engineer Rakesh Kumar. He's from Muzaffarpur and he's an independent consultant. He's saying how to calculate thickness of base plate and using stiffener when moments are acting. No, so you can refer some books which give you calculations. So if this is your column and this blue is your column and orange is your base plate, and let's say your bolt arrangement is like this. First, you need to find out the, let's say Py plus M by Z you do. From here, you will get the pressures. As per pressure, maximum pressure, you need to do the bearing check. For the negative pressure, you will have to find out the bolt reactions. Once you do the bolt reactions, then whatever stiffener plate assembly you have come up with, the easiest way is to calculate the bearing pressures at different locations. Those may be tensile or uh, compressive. If it's a tensile bearing pressure, that will be taken by bolts. If it's a compressive bearing pressure will be resisted by the base plate. So once you get the base plate reaction, sorry, once you get the pressure below the base plate, then from the bearing check, like we do for footings, you can calculate the base plate thickness. Assume that these stiffeners are helping you to provide a restraint, and then this becomes your panel size. Okay. Now in this panel size, this edge is supported by the stiffener, this edge is supported by the stiffener, this edge is supported by the stiffener, this edge is free. So you may try and refer to the coefficients as given in IS 456, although they are not given for steel, but we are still using them because they give you the two-way slab action. Uh, let's say for one edge discontinuous. It's not a very correct way of doing it, but I'm just giving you an approximate approach. So from there, what you can find out, depending on the Ly Lx, you can find out the moments. Once you get the moments, then you can find out the base plate thickness. Okay, so for stiffeners, this is an approximate way that you can use. These processes are given in textbooks also, so you can refer to any good textbook and you will find the uh, similar process given over there. Okay, all right. So these were the queries from the Google form. Now let us see if we have any query in the uh, comments, live comments. Insane Shri is asking, I have seen many consultants model column in safe. I don't get the logic. I think this comment was related to an earlier question that we were discussing. So this comment is not a question in itself. This was more to do with the one of the earlier queries. All right. So anything else? Because we have taken up all the queries from the Google form and email. So any comment, any questions from the live comments? We'll just wait for a couple of minutes just to see if there are any questions in the live comments. Yes, please. Mr. Akash Babar is saying my building has underground water tank and pump room in one portion of the basement and retaining wall in some another portion. Water tank walls and basement walls are connected to building. Should these walls be modeled? What should be the modifiers? No, so yes, they should be modeled. They should be modeled. And modifiers, I don't know. I mean, if it's part of your 16700 tall buildings, if your building is if that is applicable as per the tall buildings, then maybe uh, you should provide some modifiers. Now, although for for the walls, I guess the modifiers are not very clearly given, but these types of retaining walls and water tank walls, they will have the out of plane moments. Their behavior will be different from the RCC structural shear walls, right? Because RCC structural shear walls are supposed to take in plane moments, but these basement walls or retaining walls will be required to take out of plane moments. So for them, the modifier, it's not very clearly given for in the code. Maybe you could use the modifiers for slabs, because the slabs are also for out of plane moments. So maybe you can use the slab modifiers in such cases. Mr. Manikandan is asking, are you going to plan any course regarding the latest revision of IS 1893? Yeah, in the upcoming months, we will do a course, because still, as per the notification, May 2026 is the limit, or let's say May 2026 is the deadline after which the new IS 1893 will be applicable. So the new parts of IS 1893, I think part 1, part 5, these will be applicable from May 26 onwards. So we still have time. So in the coming months, we will do a course on the updated thing. I was thinking of doing a course when we get the updated 13920 also. Okay. So I was waiting for that. Let's see if we do get the revised 13920. It will be better, because in one course we will be able to cover the design and detailing aspects both, analysis aspects and design aspects and detailing aspects. So let's see. I was waiting for it. I am waiting for it rather. Mr. Harish Acharya is saying, I have asked a doubt about flared shear walls in last week for that as per your suggestion. But if I run the shear wall design check, reinforcement will not be showing. No, you have to. I have not done flared shear walls myself. You have to try it out in elevation. If this is the type of flared shear wall you are getting in elevation, you assign one peer label to all of them. I think it should give you the reinforcement. It will give you. I don't see why it will not give you reinforcement. You can do a meshing like this, so it will give you the reinforcements. It should give you. This is the elevation I have shown. So it will consider different sections at different heights, and as per the axial forces, out of plane and in plane movements, it should give you the reinforcement. So I have never tried it myself, but ETABS, if you assign the peer labels, you just assign one peer label from top to bottom, it should give you the reinforcements. It will also give you the shear reinforcements and the flexural reinforcements. Okay, anything else? So I think that's all for this week then. Thank you very much for joining. And now we will see you next week. So throughout the week, if you have queries, You can just keep on adding your queries in the Google form. As you all know, that remains the same. And then once every week when we meet, we will take up your queries. Mr. Akash Babar is asking, what are your initial thoughts on new 1893? To be honest, I have not gone through 1893 till now. Neither did I go through the drafts, or I went through the revised version that has been launched. So I have no thoughts right now. Yeah, no thoughts. But what I have heard is that they are trying to make it in line with the AC 7 and the other international earthquake loading codes. So the probability levels have been revised. They have now started giving you the mean recurrence interval, and they have started giving you the different uh, I mean, the earthquake forces are given as per the mean recurrence interval periods. So I think those types of things they have included. Although I have not read the draft, I did not read the draft also, and I have not read the revised version also. So as of now, I don't know much about the revised code. Okay. All right. So that's it for this week. You can continue to put your queries on this Google form. This remains the same, and once every week when we meet, we will take up the queries from here. And if you want to connect with us on WhatsApp, this is the link through which you can connect with us on WhatsApp. Uh, yeah, so that's it then for this episode. Thank you, and see you next week now. Bye bye.